Hey there, this is Trevor Peck with my second artifact. This is going to be my algorithms and data structures artifact. What I plan to do here is take an existing program and make it more efficient. This is a pretty cool program that's made to simulate the growth of mycelium. Mycelium is what mushrooms are made of. It's somewhat akin to the roots of a seed and how they grow. So obviously when the roots are finished growing, a little mushroom pops up. I just found it fascinating how they grew. So this is what it looks like in its current form. This is using a process called diffusion limited aggregation. What that basically means is that all of these dots right here are diffuse. They're also limited by the bounds of this square, and they're aggregating when they touch a stuck dot. Every single frame, these dots are being moved around, and they're performing checks to see if they're touching another dot that's stuck. Basically, when they touch that dot that's stuck, they also become stuck. Now, this lag you're seeing is not actually because of recording. It actually is this slow. The reason for that is because it is doing all these checks every single frame. When you're checking against every single other dot for every single dot, you're going to be doing a lot of checks. So literally, this is an exponential algorithm, which means it does not scale well at all. So the more dots you have, the slower it's going to get in an exponential fashion. So what I plan to do here is implement something called a quad tree. A quad tree is used in video games quite a lot, actually, as well as other rendering applications to test collisions between different entities. If you want to look at an example of what a quad tree looks like in action, this is basically what it looks like. So what we're going to do is subdivide this screen into 4 different quadrants if a certain quadrant has a lot of dots in it. Basically, if it exceeds a number, any arbitrary number that the user or the programmer might pick, then it subdivides. And when those checks happen, you're only going to check to see if there's a collision within the section that it's in. So what this is going to do is it's going to take it from an O of n squared algorithm to down to best case and usual case O log of n. So that's going to speed it up quite a bit, and so you should be able to have a lot more dots in one screen without it slowing down. And with the current amount of dots, it should be, of course, way sped up. So let's go ahead and do a review on this code so far. Keep in mind, this is going to be completely restructured because of the way that quad trees work. Right now, we're basically just using a list and iterating over that list and checking every single dot. So very basic data structure that we're going to completely revamp into something that doesn't really exist in conventional, just standard library sort of stuff. So let's go ahead and go over the structure of this code. It is completely incorrectly. It completely and correctly implements the design of this program. There's no errors that are thrown, as far as I'm aware, so it does work. However, there's no coding standard. There's no really coding standard that's followed here. You can really notice that by the way these constants are set up top. They're actually declared as just variables, when in fact, this shrink could be a constant. Iterations could be a constant as well. Radius. These are all things that could be declared a constant or final. So that's something that needs to be fixed up. And granted, this is a really short program, but I guess it'll make it quick to go over. You can see here that there's a lot of code that's still just commented out and just kind of scattered. I think there's more in Walker, yeah. When I was testing some stuff out, I just commented out. It's the easiest way to get rid of it temporarily. And you can see it's just kind of still there. It's still hanging out. So that needs to be gotten rid of. Speaking of commented, it's not. Nothing is commented here at all. I was kind of a fool when I started programming at first. I thought it kind of looked unprofessional to leave comments, ironically, throughout your code. I never intended to publish this, but whenever I did program, I try not to leave comments in my code as far as, describing my thoughts, just because I felt like it made me seem less smart. But now I know that it's completely necessary to leave comments scattered throughout code that give descriptive explanations of what's going on. So that way, when I come and look at this, I don't have to sit there and study it for a few minutes to understand what's going on. Neither do other programmers. So yeah, when I do recreate this data structure and all that, I'm going to comment it quite thoroughly. let's see here. As far as variables, there is just one unused variable. I'm not really sure why this is here. We could just delete this and get rid of that altogether, but I'll leave here because it was there. Nothing on this page as far as unused variables. All in all, it's really just, it lacks organization. It lacks comments. It barely works, but it does work. So I'm excited to kind of revamp this. It's going to be completely reworked. It should be a lot more impressive once I'm finished with the final version. Thank you for listening to my code review. I think that completes everything.